Okay, so today we're going to look at a few things. We're going to look at a binary matrix, a permutation, and communication matrices. Okay, so the first one is a binary matrix. A binary matrix simply means it just has ones and zeros in it. So if binary, I think if you do some computing, I think they call it binary coding, and you only have ones and zeros. So that's what a binary matrix is. So the only thing you really need to realize is if they said, use a binary matrix, so make sure it only has ones and zeros. So a permutation matrix is it is a type of binary matrix, so that means it only will have ones and zeros. But a permutation only has a 1 in each row and each column. So if you see, and it's always going to be square as well. So what a permutation matrix does is it's used to rearrange another matrix. So if you have a look here, if we look at, we've got this matrix X. So instead of putting numbers in the matrix, they've actually just got letters. And it's so that you can see how a permutation will move it. So if you have a look, this one is a 3 by 1, and then they've got this permutation that they've created, which is a 3 by 3. So you'll notice in this permutation matrix, see how there's only a 1 in each row and each column. Okay, so what we're going to do is we can see if we pre-multiply that permutation. So here's the permutation with that matrix X. So we have to pre-multiply because otherwise it wouldn't be defined. So if you look at it, when you pre-multiply, so just practicing our multiplication skills, we would go to get this first answer here, you would be using this row 1 with this column there. So you can see 0 times t, anything times 0 is 0. So you can see what happens is where the 1 is, that it makes that letter appear. So now you've got the R, instead of being at the bottom, it's now on the top. And you can see here, if we were doing this middle answer, we'd be using the middle line. So you can see the 1 is in that center, so that means the A is going to show. And that's what. So you can see, if you slow it out, you can see that by using that permutation, I've rearranged that matrix that had TAR to be RAT. Okay, so I could then use the permutation again. So that means, I could either say you're going to do the permutation times that X, or they can just call it P squared. Sorry, that's a big X. And then we can see when we did that, we ended up back at the same thing. So if you notice, when you squared, in this example, when you squared the permutation matrix, you got the identity. So that was like a number 1, so it would cause it to be the same thing. All right, so let's have an example. It says find a permutation matrix that takes this column matrix to this one. So you can see that you want to rearrange the letters. So this is what it originally is, and you want it to end like this. So you can see you have a 4 by 1, and obviously you're going to end up with a 4 by 1. Now we said that a permutation is a square matrix, so it'll have to be at the front. So I'm going to have a permutation, and it's going to be a 4 by 4, because we're going to multiply it with this 4 by 1, which has A, B, C, and D. So let's get it ready. So let's get it set up. So I'm going to draw this 4 by 4. I'm going to get it ready. So we'll have 4 columns and 4 rows. So I'm just sort of highlighting where we're going to see the elements, okay? All right, so then we will be multiplying it by our A, B, C, D, sorry, even. And we want it, when we do that, we want it to end up with D at the top, C next, then B, then A. So what you're saying is essentially if we were when we're trying to work out this element, when we've got multiplication, wouldn't we use this row and we'd go down that column? So because we want the D to show, I'm going to put a 1 where the D is, which is the last spot, and I'd put a 0 elsewhere. So when I run and dive, it ends up producing a D at the top. So the next one I want a C to show. So in the next row, where am I going to put that 1? I want C to show, so wouldn't it be in the third one? Yes? So we're going to go, what we'd be doing would we go this, would get multiplied down there, and because the 1 is on the C, it will end up there. Does that make sense? Yeah? So then, if I'm doing this fourth row, I'm going to go fourth and I'm going to go down there. What I want is the B to show. So where's the 1 going to be? The second, good. And the rest will be 0. And the last one, I want A to show. So, yeah, awesome. So we've worked it out. There's the permutation. So this is the permutation matrix we would need. Okay, so that could be the answer there. So we've got a permutation matrix and we're applying it to a 4x1 matrix A that gives the column matrix. So what they're saying, as someone pointed out to me, it was P times matrix A, the permutation, and we're going to get this X, Y, Z, W. All right, very good. So what we're going to do is we've got the permutation matrix already. So I'll write that out just so you can see what's happening. All right, so there we go. Okay, so we're going to times it by, so this is the one we've got to work out, this matrix A. Okay, and we know when we do that, we're going to end up with the X, the Y, the Z, and the W. So we can see when we've got this letter here, X, obviously when we go down and we would run down here, we want X to show on the third spot, yeah? Because that's where the 1 is. So there'll be, so it's like 1, 2, and then we've got X there. Okay, if I'm doing the next row, so it'd be this is how I'm going to get that. So I need Y to show, and so it's the 1 is in the last spot, so we're going to have Y down here, okay? So then if we look at this one here, this we go run and we're diving down, we want the third one to show Z, so the 1's on the second spot, so we'll put Z there, and then what's the last one, we want W to show. So we do W there, okay? Okay, so with this one, this exam question, you've got a permutation matrix here. So you can see here you've got a permutation matrix and you're timesing it by something else. So they want you to say what it's equal to. So if you want, just put an equal sign, chuck it, your little answer there, and let's just do it and see what we get. So if we were going across this row, now the 1 is on the fourth one down, so 1, 2, 3, so there's the 4, so the P is going to show first. Then if I do the second row, yeah, the 1 is on the third one, so 1, 2, 3, so the A is going to show. The next one, the third row, the 1 is on the first letter, so then the L is going to show. Okay, and then I'll keep going. Yeah, no? This is the fourth line. The 1 is on the second, so E is going to show, and then we've got S left, and that makes sense. It's both on the last. So our answer to this question is D. The matrix P is a 4x4 permutation. The matrix W is another matrix such that the matrix product P times W is defined. So, okay, that's good. So we know if we've got matrix P, and they said that's a 4 by 4, and they said they're going to multiply it with W, and they're saying it's defined, so I know that's definitely a 4. And the matrix product will result in the entire first and third column of matrix W being swapped, and the permutation matrix for that is. So what they're going to do, so let's just say it's a 4 by 1 because we're doing a permutation. Now you don't know, you don't have any letters, but we want one that's going to swap the first and second position. So what happened if I wrote it out like this? So let's do a 4 by 4. This is my permutation. So this is, a 4 by 4. Now we're timesing it with W. Now what I'm going to do is I'm just going to, because this is a 4, I'm just going to go 1, 2, 3, 4. I'm going to put the numbers 1, 2, 3, 4. And what they said is they want the first row and they want to swap the first and the third row. So what that means is, if I just had numbers there, we want the 3 to be here, we don't want 2 to move, and we want 1 to be there, and the 4th. So can you see how I've swapped them around? Yeah? So now what you want to do is we're going to go, if we're doing this, we're going across the first line. So we'll have 1, 2, 3, 4 spots. We want number 3 to show. So if I want 3 to show, it's the third one down, so it has a 1 there. Does that make sense? Okay. Now, I didn't want 2 to swap, so I want 2 to show. So where will my 1 be on that second row? Yeah, good. Now, the next number, I want it to be 1 there now. So which one, where do I want my 1 to be the first one? Yeah. And my last one, I don't want 4th to be swapped, so it'll be in the last spot. So which answer is that? Our permutation is? So we got this, it's the same as B. Okay. Matrix K is a permutation. All right, there's K, sorry. Okay. Matrix M is a column matrix that is multiplied once by matrix K. So M is multiplied once by matrix K to obtain P. That's a bit nasty because normally they call the permutations P. That's probably why I was going off on the wrong agenda there. So they said when you do this, when matrix M is multiplied by K, the element M31 moves 2. So what you're saying, because we can't see the numbers, so this one we could just put them in. So I'm just making it up again. 1, 2, 3, 4, and 5. So when they say element M31, they mean row 3, obviously column 1. So they wanted to say, where does that 3 go to once you use this permutation? So let's just work it out. So if I go the first line, it's the third letter down, the third number down, so 1, 2, 3. So 1, 2, 3, that's actually our 3. So we've already seen where it moves in the first go. So what would you label that element? It's in matrix P, it's in row 1, column 1. So where's my answer? A. So that's what you have to do. Okay, so today we're looking at communication matrices as well. So a communication matrix is a square binary. So remember, that just means ones and zeros, okay? And the ones represent when there's a link between two things. Like we say communication, and often they use, say, people talking, but it can mean other things in real life. It can be machinery, so a machine can communicate with another machine and they would use it like that to set it up. So let's have a look anyway. So what you have is that people, when you have communication, obviously if I can communicate with another person, that means it can come back. Obviously it works both ways. So you'll see here, when we're setting up our what we call our one-step communication. So one-step communication is direct communication. So if you might want to put that is direct communication. So that means you directly talk to that person. Okay, so we know it says up there that it's a square matrix. So if you look at this example, we have 1, 2, 3, 4. We've got 4 people that we are going to set up a communication. So when you have these 4 people, what you often do is you put their letters down the side. So we've got E, W, Y, and K. Now, because I've gone that order, I'm going to go the same. You have to have the same order across. So maybe make a little note of that is the same order there. So what I mean is EWK, EWYK is along that way. Okay, so you give a 1 if you can communicate with a person. So if you look at Eva can talk here. She can talk to Wong only. So what I'll do, between Eva and Wong, there's a 0. Now, we never say, there's no point communicating with yourself. You already know the information. So we'll see zeros when you have the same letter. So, and you'll notice that the same letter, like W to W, Y to Y, and K to K, they're on the diagonal there. So this is what, we've got a diagonal there. You'll see the zeros, and that's, you don't talk to yourself. So we often call that the redundant link, because it's, it's pointless. It's going back to the same thing. So that's a redundant link. So you can step up, you can put the zeros in when you're setting it up straight away. Now, we said Eva couldn't talk to the other 2, so we put that. Now, if you look at Wong can talk to everyone, so we'll put a Y across there. If you look at, what was Y? Yumi can only talk to Wong, and Kim can only talk to Wong as well. Okay, so that is our one-step communication, and we are often represent that with a capital C. So we'll say C is our one-step communication matrix. So, however, so this is the scenario. So we can see Wong speaks a lot of languages and can obviously communicate. So what we're going to do is Eva's going to try, she wants to get a message to Kim. So she's going to have to go through, so Eva has to go through Wong to Kim. So you can see, sorry, I'll do that in different class. So when you have to use that, you can see it is a 2-step communication. So say, for example, you might put that there, where Eva went to Wong, that then went to, say, Kim. That is, so these little arrows, that's a step, that's a step. So we call that 2-step communication link. That's her link. So the 2-step communication matrix is actually, you can work it out is by simply taking the communication one and squaring it. So raising it to, if you want to write in there, raising to the power of 2, yeah? So that's what we can do. Or you could do, see down here, they've done it. They've got the communication by the communication. That's the same as squaring it. And so here, this is what we call C squared, or the 2 steps. So this is showing me all the 2-step combinations. So this one is like, so this is showing how many 2-step options there are. Okay, so very important. It's just telling you the options there are available. So if you have a look, we say down here, so this is what we were talking about before. If you were doing 2 steps, so say Eva can go send a message to Wong and then back to herself. So that's her 1 step. That's her 1 option of 2-step communication. So that's what that one is. But anyway, why would you send it back to yourself? So we call this the redundant link. So let's just call that.
Can we replace that with zeros?
No, you can just leave it like that. We'll leave it there because it's an option, but it's a little bit pointless. And it would be pointless in the computing world as well. They're not sending a message out just to come, to get back to themselves. So what I wanted to show you is, like, say for example, so you've really got to make sure that you understand what a 2-step's showing you. So take this number here. This is between Eva and Yummy or whatever. So what this is saying, that we have 1 option of a 2-step, and that's where Eva would send it to Wong and there. So there's the 1 option. So this is, maybe right after it, this is the 1 option that is stated in the C-squared. Okay? So you've got to be really careful with that. So if I just going to highlight another one, just so you're clear. So say if I highlighted that combination, that's between Eva and Kim. So what it's saying, Eva can get, there's 1 option where Eva can get a message to Kim via 2 steps. And we know it's Eva to Wong to Kim. Okay? So that 1 equals the 1. So the 1 indicates the 1 option, the 1 2-step option, I should say, the 1 2-step option there is between Eva and Kim. Okay, so we know about the redundant link, so there's a little bit of a blurb there to know. So we don't really care about when, and we wouldn't normally ask you questions about it because it's not relevant. We want you to talk about real stuff. So the redundant spot. So what they do, they often say, we want to know, sometimes they'll say, well, who's the best communicator? And there might not be, it's pretty easy with this one. Wong's, you can clearly see. But when sometimes you have other ones, it may not be so clear who's the best communicator via that. So what they'll say is, finally, the total number of 1-step communication links, 1 and 2-step communication links can be found by. So sometimes they say that. So they'll say the best communicator is the person who has the most 1 and 2-step communication links. So you can see here, this was C, and this was what C squared was, and you add them together and you get this matrix here. So then what we do is we often tally up this final one, and we would say, all right, E had 4 of those 1 and 2 steps.
Including the redundant links?
Yeah, include the redundant links. Then these ones we would say, what's that, 6, this one's 4, and this one's 4. And we could see that. We could see that Wong was, but that would say Wong is the best, had the highest. They might say you to rank them. So then, in this case, it's a little bit hard because they're all on 4. But if they were different, you might rank them highest to lowest, lowest to highest. Just got to read the question. What are they telling you? They will tell you how to calculate the communication. So they say, look, we might decide on just 2 steps. They'll say, we just want to know who's the best 2-step communicator. So you would just add up the 2 steps. Okay, so be really careful. So let's have a look at some examples. So question 7 here, it says the communication matrix below shows the direct paths by which messages can be sent between two people in a group of 6 people, U to Z. They're always going to say this comment here. It's pretty much a 1 means a person can directly communicate. It's pretty much what we know a communication matrix is. Okay, now it says, for example, and they'll give you an example. Now, it says, how many ways can Y get a message to W by sending it directly to one other person? So this, when they ask that, if you're going to go to another person and then to W, that's really what they're saying is how many two-step links between Y and W. Okay? So you could go about it. You've got pretty much been given C up here, this communication. So one way it could be you could just go find C squared and then see what number there is between Y and W. Or what I did, I just thought it was a little bit easier. I thought I'm just going to go to Y and see Y can directly send, who can it directly send to. So I went and looked. So here's Y. So Y can directly send to W, X, and Z. Okay. So then we want to go to W. So we're not going to go, it's not going to be 2 steps to W. So we're looking at X and Y. Now, can X send a message to W? No. So X can't send it. It can only send it to V, Y, and Z. Can Z send it to W? No. So Z can only send it to Y, V, U, and X. So how many two-step communications is there between Y and W? What is the answer, boys? 0. That's correct. Okay, question 2. The main computer system in Eleanor's office has broken down. 5 staff members, A, B, C, D, and E, are having problems sending information to each other. The matrix M shows the available communication links between the staff members. And once again, here they go. They just blurb out what a 1 means and what a 0 means. So which 2 staff members can send information directly to each other? So what are we looking at? Who can directly send a message to each other? So if you look at A can send it, if you look, can go to B and E. So if you go to B, but can B send to A? No, so that's not an option. And can E send to A? No. So that's not.
Just look for which one's symmetrical.
Yeah. So what Charles is saying there. So he said the ones that there's a 1 in each, both of the pairs. So he's saying it's symmetric. So when you can see which one is it, if I have a look at B can send it to D. So C, B, and D, and then D and B is also there. Okay. So all you needed to write is B and D. Okay? Alright, next part. So Eleanor needs to send documents to Chai. Which of the sequence, what is the sequence of communication links that will successfully get the information from Eleanor to Chai? So wait a minute, I'm going to get that. Alright, boys. So Ella needs to get documents to Chai, and you need to go through the sequence. How is that going to work? So obviously we need to start at Eleanor. Now Eleanor can only go to D. So that's the first thing you're going to do. So Eleanor to the D. So now you're on D. So the next step is, who can D go to? D can go to B. So we've gone, all right, so we're going to B. Now we're on B, so we go up to B, and they want to get to Chai. So if they can get to Chai, which they can, so then we go B to C. So there's the pathway that you need to show. So I've seen a question not like similar to this in terms of you're going through the options. It wasn't names, it was they used the matrix to decide what choice they chose in an multiple choice. So you had to just keep linking through. So it sort of looks like a permutation, but anyway. All right, so let's keep going. And it says the matrix M squared below is a square matrix of M, which shows the two-step communication links between the staff members. Only one pair of individuals has two different two-step communication links. So you're looking for the two. Where's that two? And it's here, and it's between A and D. So what that tells me that there's two options of two-step links between A. So A is going to send it to someone else that goes to D, and there's two options. So what are those options? Who can A talk to, who can then talk to D? I think you can go to, if you look up here, A can go to B, so B means, and then it could go to D, and then who else can A talk to? E. So there's the two options, okay?